Hey everyone, welcome back to the channel Code with AKJ. Today is day 20 of solving LeetCode 75 challenge, and today we are going to be solving questions from hash map or set technique. So we'll go step by step from a brute force solution to an optimal solution. So if you are new here, don't forget to subscribe and hit that bell icon for more coding tutorials. So let's get started. Today's question is find the difference of two arrays. So given question here, given two zero indexed integer arrays nums1 and nums2, return a list answer of size 2, where answer of 0 is a list of all distinct integers in nums1 which are not present in nums2, and answer of 1 is a list of all distinct integers in nums2 which is not present in nums1. So the problem is simple here, given two arrays nums1 and nums2, and you need to find all distinct integers in nums1 and nums2. So given example here, nums1 is 1, 2, 3 and nums2 is 2, 4, 6, and we need to check distinct integers from both arrays nums1 and nums2. From the given explanation here, for nums1, the value 2 is present at index 0 of nums2, whereas the value 1 and 3 are not present in nums2. So therefore, since 1 and 3 are not present in nums2, we'll include that two values in our vector. Same goes with nums2. We need to check each and every element which are not present in nums1. So from this given array, we can observe that 4 and 6 are not present in nums1. So we'll include these two numbers in our result vector. So finally, our result vector contains values 1, 3 and 4, 6. So given example 2 here, nums1 contains values 1, 2, 3, 3 and nums2 contains 1, 1, 2, 2. And from the following explanation and following two arrays, we can observe that 3 is not present in nums2, and in nums2 we have values 1, 1 and 2, 2 which are present in nums1. So the second answer, that is answer of 1, would be an empty array because every numbers in nums2 array are present in nums1. So now that we have understood the problem, so let's dive into the solution. So let's start with our brute force approach. Here we'll use nested loops to compare every element of nums1 with every element of nums2. So it's quite simple. So let's quickly dry run this and let's quickly move on to our code. So here I've taken nums1 and nums2 array and we'll use the for loop and we'll check for every element of nums1 which is present in nums2 or not. So if it is present, we'll take a boolean variable which will be initially false. So we'll use a for loop here, and for every element in nums1 we'll check whether it exists in nums2 or not. So if we found that particular element, we'll mark our boolean variable from false to true. And after finishing our second for loop, if the boolean variable is still false, then we'll include that particular number in our vector. And if not, we'll continue with our next element. So let's quickly dry run our brute force approach with this given example. So we'll check whether 1 exists in nums2 or not. So it does not exist. So the boolean variable becomes false and we'll include that in our vector, that is 1. And we'll move to our next value, that is 2. Since 2 is present in nums2, our boolean variable changes from false to true and will not include this particular element in our vector. And finally, the value 3, which is not present in nums2, so the boolean value remains false itself, so we'll include that in our vector. So after finishing our first loop and checking for elements exist in nums2 or not for the given nums1 array, the answer of 0 vector consists of values 1 and 3. Same goes with nums2 array, where we'll check every index value whether this particular element exists in nums1 or not, and after checking we'll get our answer vector as 4 and 6 which are not present in nums1 array. So this would be our brute force approach. So the time complexity of this approach would be O of n square, as we are using nested loops to check for each and every element exists in second array or not, and space complexity here would be O of 1. So let's quickly write this code and let's submit. So here's the code for our brute force approach, where we will use nested loop to check each and every element whether it exists in second array or not. So I've taken two vectors, diff1 and diff2. So the first for loop is for finding the elements in nums1 but not in nums2. So it will iterate over nums1 array, and we have taken a found bool variable. If we found that value in our second vector, we'll mark our found variable to true and we'll break that from the loop. And before inserting that particular value in our vector, we'll check whether the value is already present in our diff1 vector for uniqueness of our integers. So since it is a list of all distinct integers, we can observe that from the example 2, we have duplicate values in our vector to handle that case also. So to handle that particular case, we need to check that found variable is true or not, and we already have a value present in our diff1 vector or not. So if these two conditions satisfy, we'll insert that nums of 1. Same goes for our nums2, where we find elements which are not present in nums1. And finally, we'll return our vector diff1 and diff2. So let's quickly run this code. So again, so let's submit. As you can see, this approach gives successful submission, but here the time complexity would be O of n square and space complexity would be O of 1, as we are not using any external data structure. So while the brute force approach works, but it is inefficient because of its time complexity. So let's optimize it using sets to handle uniqueness and membership check efficiently. So here I have taken two examples, example 1 and example 2. So in our optimal approach, our steps here would be to convert these both arrays into sets, and we'll use set difference operations to find element in one set but not the other. So our first step here would be to convert these two arrays into sets. So the set 1 contains 1, 2, 3 in this case, and set 2 contains 2, 4 and 6 in this case. And coming to the second example, the set 1 contains 1, 2 and 3, and set 2 contains 1 and 2. So in this way, by using this given step, we'll handle these duplicate elements in this array. Finally, after converting these both arrays into sets, we'll check whether this given element is present in another set or not using a find function which is present in set. And in this way, we'll able to differentiate all the elements which are not present in another array. So this would be our optimal approach. So the time complexity of our optimal approach would be O of n plus m, as the find function takes n plus m time complexity, and whereas space complexity here would be O of n plus m as well, where we are trying to store our vector elements into set. So let's quickly move on to our code and let's submit. So here's the code for our optimal approach. Here these two lines 4 and 5 is about converting these both vectors into set, and we have taken same two vectors diff1 and diff2 to store all our answer variables, distinct integers in nums1 which are not present in nums2, and distinct integers in nums2 which are not present in nums1. These two for loops checks whether given element is present in another set or not using find function. And if it is not present, we'll insert that particular element in our diff1 for our nums1 vector, and this for loop is for finding the element which are not present in nums1 or set 1, and if it is not present, we'll insert that value in our diff2 for our nums2 vector. So after finding these values and inserting in our resultant vectors, we'll return those two vectors diff1 and diff2. So let's quickly run this code. So okay, so let's submit. As you can see, this approach also gives us a successful submission. So let's quickly analyze the time complexity and space complexity of both the approaches we have discussed. So brute force approach takes O of n square time complexity and O of 1 space complexity, whereas in our optimal approach, where we have used set to handle uniqueness, it took O of n plus m time complexity and O of n plus m space complexity. So in this way, we have optimized our time complexity from O of n squared to O of n plus m, where n and m are the size of both vectors nums1 and nums2, whereas we compromised with our space complexity, where it has slightly increased from O of 1 to O of n plus n as well, where we have used sets to store the vector elements. And that's it for today's video. We went from a brute force approach to an optimized solution using sets. So if you found this video helpful, please give it a thumbs up and share it with your friends. Don't forget to subscribe for more coding tutorials. I'll see you in the next video. Thank you.